and welcome to this video from Heybridge Maths Department. This video is about solving systems of inequalities and representing the solutions on number lines. Our first question is find the set of values of x which satisfy 3 is less than x is less than 9 and x plus 1 is less than 7. So the compound inequality on the left-hand side is already in a form that I can represent on a number line, but I need to solve this inequality on the right. So I've got x plus 1 is less than 7, and I'm going to subtract 1 from both sides, and that will then show me that x is less than 6. And I'm now going to represent both of these inequalities on this number line. So the first one, 3 is less than x is less than 9. And I've used open circles because the values 3 and 9 wouldn't satisfy 3 is less than x is less than 9. And then I've got x is less than 6. So again an open circle. And now I need to look and see whereabouts on my number line these two sets of values overlap. So I can see that I've got 3 and I can see that I've got 6 there. So the set of values that satisfies both inequalities would be 3 is less than x is less than 6. Because looking at this overlapping region, this is where they overlap, between 3 and 6. So my next question, find the set of values of x which satisfy minus 2 is less than or equal to x and x plus 3 is less than 4. So again, I need to solve this right-hand inequality. So I've got x plus 3 is less than 4. I'm going to subtract 3 from both sides, and that will leave me with x is less than 1. Now in this case, I can actually put these two together into a compound inequality because I know that x is greater than or equal to minus 2. And I also know that x is less than 1. So I can actually write that as minus 2 is less than or equal to x is less than 1. And then I can represent that on my number line. So I'm going to put a solid circle at minus 2 because that's included in the set of values of x which satisfy both inequalities. And I'm going to put an open circle at 1 because that isn't included in that set of values of x which satisfies both inequalities. So that's a representation of the set of values of x which satisfy those two inequalities. Now this time I've got two inequalities that I need to solve before I can represent my answers on a number line. So I've got x minus 3 is greater than or equal to minus 8, and I've got x plus 3 is less than 11. So let's start off with my left-hand inequality. So I've got x minus 3 is greater than or equal to minus 8. So I'm going to add 3 to both sides. Remember, solving inequalities is pretty much the same as solving algebraic equations. You just need to remember that you have inequality signs in there instead of equal signs. So I'm going to get x is greater than or equal to minus 5. And then if I move across to my right-hand side, I'm going to have x plus 3 is less than 11. And I'm going to subtract 3 from both sides, and that's going to give me x is less than 8. So x is greater than or equal to minus 5, and x is less than 8. So again, I can write this as a compound inequality. Minus 5 is less than or equal to 8, x is less than 8. Minus 5 is less than or equal to x is less than 8. And then I'm going to represent that on my number line. So solid circle at 5, open circle at 8, and that's a representation of the set of values of x which satisfy those two inequalities. So the same again, we've got two inequalities that we need to solve before we can represent our solutions on the number line. So if we start on the left hand side again, 4x plus 7 is greater than 3. We'll subtract 7 from each side. So 4x is greater than minus 4. Then we're going to divide both sides by 4. So that's going to give us x is greater than minus 1. And then if we move across to the right hand side and solve this inequality, we've got 7 is less than 11 add 2x. So we're going to subtract 11 from both sides. So we will get 6 is less than 2x. And then we're going to divide both sides by 2. So 3 is less than x. So in this case, we can't actually put these together as a compound inequality because x is greater than minus 1 and x is greater than 3. So if we put an open circle at minus 1, there we go. That shows us that x is greater than minus 1. And then if we also put an open circle at 3, and that shows us that x is greater than 3. So our solution to this would be that x is greater than 3 because the two solutions to the two linear equations overlap for all values of x that are greater than 3. So those are all the values of x that will satisfy both linear equations. Right, so final question now. So again, we've got two linear inequalities to solve. So we'll start on the left hand side. So we've got 3x plus 2 is less than or equal to 27. So I'm going to divide both sides by 3. And that's going to give me x plus 2 is less than or equal to 9. And then I'm going to subtract 2 from both sides. So that will give me x is less than or equal to 7. Now let's do the right hand side. So I've got 4x add 3 is greater than 23. So I'm going to subtract 3 from both sides. That will give me 4x is greater than 20. Then I'm going to divide both sides by 4. And that will give me x is greater than 5. So I've got x is less than or equal to 7 and x is greater than 5. So I can pop these into a compound inequality. So I'm going to have 5 is less than x is less than or equal to 7. Then I can represent this on my number line. So I'm going to draw an open circle at 5 and I'm going to draw a closed circle at 7, solid circle, and then I'm just going to draw a straight line to join the two up. And that shows the range of values that satisfies both inequalities. Thank you for watching.